Okay, 5 and 6, here we go. Number 5, y equals -4 times the absolute value, x plus 1 plus 9. Okay, so again, parent function absolute value. I graph that V-shaped parent function on my grid like that, and then I look at my equation and I think about my transformation. So here I've got 4 of them again. I've got that vertical flip, I've got that times 4 multiplier, and then I've got plus 1 h value plus 9 k value. Yikes. So let's draw those. So up 9, left 1, that's from these two. And then that times 4 multiplier means a vertical stretch. Sorry for my messy handwriting. And then that negative means a vertical flip as well. Wow. So let's do all that, okay? So again, I move my origin point first. So I move left 1, up 9. Left 1, up 9 right here. So that's where my new origin point is going to be. Again, because we're flipping this vertically because of that negative a value, it's helpful to draw an axis there too if you want. So that's my new origin. And again, so two things. I'm going to flip this V shape vertically. So instead of being, that's not quite a smiley face because it's like a V, but instead of a smiley, it's going to be like a frowny, okay, going down, okay? And 4 times multiplier, big multiplier, which means this is going to be very stretched vertically. So this is going to be a lot skinnier of a V shape, almost like a capital A without the middle thing, okay? So again, it can be helpful to draw your initial, like if it wasn't flipped or stretched at all, you can draw those kind of as a reference point, okay? So again, I'm doing two things. I'm quadrupling or times 4 the distance, the vertical distance, and then I'm flipping it down. So instead of moving up 1 over 1, I'm going to move, again, it'd normally be up 4, but now it's going to be down 4 because that vertical flip. So down 4 over 1 to both sides, right? Because of the vertical flip and the 4 times multiplier. And then again, instead of up 2 and over 2 to both sides, it's going to be, again, times 4. So 8 is the vertical distance, but 8 downwards. So 1, 2, 3, 4, 5, 6, 7, 8. And then over 2 to both sides. So right there and right there. There we go. That wasn't too bad, was it? See, I told you, it looks scary, but when you know what you're doing, you can handle it, okay? So always forget about domain and range. I started number 6 real quick. But first, the domain and range. The domain is going to be all real numbers because it will extend forever from left to right. And then the range does not go up and down forever, okay? It goes down forever, but it only goes up to 9 on the y-axis. So 9, y is less than or equal to 9, okay, because it's going down forever. All the y values lower than or equal to positive 9. Hope that makes sense. Last one, number 6, another big guy. Negative 1/2 times the cube root of x plus 7 minus 4. Okay, so the parent function is a cube root. Okay, back to number 6. So cube root, okay, again, look at my equation. So I got transformations, again, 4 of them. 4 of them. Where am I going? Again, my vertical and horizontal, so h value plus 7, so that means left 7. 4, negative 4 is my k value, so that means down 4. Okay. Negative 1/2, so that negative means a vertical flip, and then that 1/2 means, again, 1/2 multiplier, so that is a vertical shrink. Okay, so it's going to be pushed down a little bit. Okay, I forgot my cube root parent function as well, so let's sketch that. Okay, it's got those cube 3 points, -1, -1, 0, 0, 1, 1, but the cube root is the one that's skinnier, so we're going -8, -2, and +8, +2. Okay, so that's my parent function, and I'm doing all these things to it, okay? So I'm shifting that origin point, I'm shifting that left 7, 1, 2, 3, 4, 5, 6, 7, left 7, and then down 4, 1, 2, 3, 4. So that's my new origin point right there, okay? And again, once you do the horizontal and vertical, draw your little guy points in here too, what it would look like if you weren't doing any of the shrinks or the flips or anything, okay? We're not going to be able to fit this leftmost point over there, but we can fit this one, right? It's over 8 and up 2 from the origin, okay? So that's where I'm looking. And I'm going to draw my imaginary axis there because I'm flipping it, okay? That can be helpful. 1/2 means what? That means I'm cutting my vertical distance in half that I would normally move, okay? And I'm flipping it vertically, okay? So let's just go 1 point at a time, okay? So I'm doing two things. I'm moving it to the other side of this imaginary axis, and I'm going to cut the distance vertically in half. So again, this point right here from the origin, I would normally move left 1, down 1, okay? But a vertical flip means I'm going to be moving up instead of down, and instead of moving down 1, I'm going to move up just a half, okay? Because again, that vertical flip and that 1/2 multiplier, okay? Same thing with this one. Again, flipping it down. So normally I would move down 1 and right 1, but again, I'm cutting that vertical distance in half, so I'm only moving down a half for that point, okay? And then this one again is normally right 8 up 2, okay? But it's going to be right 8 and then down 1 because, again, cutting the vertical distance in half and flipping it over that imaginary axis, okay? So that, again, I can't fit my 5th point on there. Could be way to the left, but that is a small picture of what my graph looks like, okay? And domain and range, nice and easy for this one. Both are all real numbers. It will extend side to side forever for the domain, and it will very gradually, but it will extend up and down forever for the range. Very nice. I hope that was helpful. Seeing a few more examples. Good job.